Systems of equations can be solved by a method called substitution. And if you think about the word substitution, it's going to tell you to substitute or simply replace. So we'll be replacing variables. So the form that we would like to use when we use substitution is when one variable is solved for. So in other words, we have one equation in my system as a y equal, or one equation in my system as an x equal, because then it's easy to substitute. Although you can do it with other methods, that would be the easiest. So the steps for this is you're going to replace or substitute one equation into another equation. Doing this will provide only one variable in which to solve for. The second step then, once you've done this, you're going to solve for the variable, and then back substitute to find the second variable. And then lastly, once you have your ordered pair, be sure to check your answer. So let's go ahead and show how this method works on a few problems. Notice it's of the correct form in which I like. Makes it a little bit easier. And what I'm going to do is replace y's with x plus 3 in my second equation. Here's a y. That y becomes x plus 3. So I'm substituting in the equivalent of y from the first equation. Now we have one variable in the equation, so we can go ahead and distribute the 5, gather my common variable x, and now we have a two-step equation. And that two-step would be first to subtract 15 from the 21. In doing so, you get 6. Solving for x, x looks like it should be 2. Now we need to back substitute. Back substitute just says replace 2 in the other equation. And notice it's already solved for y. So I'm going to put 2 into this equation. So y equals 2 plus 3. So it looks like y is equal to 5. Now we want to check our answer. Checking our answer. 5 times 5 minus 2 times 2 should be equal to 21. 25 minus 4 is 21. So we checked our answer. Looking at equation 2, it's really not set up, but we can force it to be set up for substitution. If I look, this x is by itself. In other words, there's no coefficient. So what I'm going to do is say x then is 2y plus 5. All I did was move the 2y to the other side. So now, in the second equation, I can take this value 2y plus 5, that expression, and plug it in right in there for x. In doing so, I end up with only y's in my equation. Substituting, now distributing. Make sure you realize that you're distributing a negative 3. Distributing negative 3, I get negative 6y. Distributing negative 3, I get negative 15. Now, again, gathering my y's and watching my sign. Adding 15 to both sides. I get negative 2y is equal to, adding these up, I end up with 9 and 15 is 24. Solving for y, I get y to be negative 12. Back substituting, I always go back to my x equation, and x is equal to 2 times my y value, and add to that 5, and I get negative 24 plus 5 would be negative 19. Now when I plug this in, I want to make sure that it's correct. 4 times my y value minus 3 times my x value should be equal to 9. 4 times negative 12 is negative 48. Two negatives make a positive. 3 times 19, well, 3 times 10 is 30. 3 times 9 is 27. Looks like it's positive 57. Negative 48 plus 57 is in fact 9. So the ordered pair, we want to write it as an ordered pair, negative 19, negative 12, is a solution to that system. The last equation, again, it's nice for substitution. I don't have to do any extra work. Y is solved for, so I'm going to take this expression and I'm going to substitute in for y. 2 times my y, which now becomes 2x plus 1, minus 4x equals 2, distributing, combining my like terms. Oh, I get 0. 2 is equal to 2 because my variables disappeared. Well, when is 2 equal to 2? 2 is equal to 2 always. So no matter what happens here, these two lines, if it's a solution to one, it will always be a solution to the other. So in other words, if I was to graph these lines, they would lie on top of each other. So I could pick a solution. Let's suppose I pick x to be 1. 2 times 1 is 2. 2 plus 1 is 3. That will also be a solution down here. So if I check it, I can go 2 times y minus 4 times 1 better be equal to 2, and 6 minus 4 is equal to 2. Any ordered pair I choose will work because of this scenario here. Now that's showing one solution. This is showing infinite solutions. So what would it look like then if I had no solutions? In other words, in graphing, the lines would be parallel. Well, I would still go through the same amount of work, and I might get something like this. Well, 2 is never equal to 3, so therefore no solution. So you have 3 scenarios when you get out the ordered pair and it works, when you get a situation where a value is equal to a value, and that's always true, infinite many solutions. What if it's the solution of one? It'll be the solution of the others in the system. And the last scenario is when I get 2 equal to 3 or some value equal to another that is never true, and that means the lines are parallel and there'll be no solution.